Does your company have a product or service that data professionals would benefit from? A BI tool, a cloud solution, or the kind of thing that a data skeptic listener would be interested to learn about? Reach out to advertising@dataskeptic.com. Maybe we can help you bring your message to the audience you're looking for. When I think about where I started programming-wise compared to where I am today, what surprised me most really is the development of the tooling more than the computing. Copying source code out of the backs of magazines and hoping I had the same compiler and libraries. That's a far different era from today's pull, build, push. The tooling around machine learning has had similar leaps forward. Weka, Vopal Wabbit, sklearn, H2O, XGBoost, Tensorflow, all these libraries and tools have in many ways democratized machine learning. So given that we're several episodes into our interpretability series, it's high time we touched a little bit on the tooling. Today on the show, I catch up with my friend and former coworker, Pramit Chowdhury. Pramit's brought me more than a few new interesting things to look at in the topic of interpretability and beyond, so always great to catch up with him here. We'll have that right after the break. Thanks to this week's sponsor, Brilliant.org. I'd like to encourage all of you guys to head over to Brilliant.org/dataskeptic and check out what they've going on there. In particular, start with the problem of the day. Whether you've never liked crossword puzzles or you've just outgrown them and you want something more mentally challenging, I highly recommend the problem of the day. Very engaging and very fun. That's actually what led me into Brilliant in the first place and got me started moving on to exploring some of their guided courses. There's lots of topics in math, science, and CS. In particular, I want to highlight the new interactive calculus and neural networks course. Guys, this is really important. If you want to work on TensorFlow and to get into deep learning and all that stuff, you need to get your linear algebra down, you need to know calculus and the gradients, and an excellent place for you to develop those skills is by heading over to Brilliant.org/dataskeptic and seeing which of the guided courses are right for you, be it that calculus and neural networks one, which is new, or one of the many others I've recommended before. One more time, head over to Brilliant.org/dataskeptic. Hey Data Skeptic listeners, we're launching another survey and we'd like your help. If you've got 2 minutes to spare, please take our survey at dataskeptic.com/survey. Your feedback helps us deliver the quality content you can find from Data Skeptic, and you might just win a free t-shirt. So do me a favor and head over to dataskeptic.com/survey and tell us about yourself.
Hi, my name is Pramit Chaudhary. I'm currently a lead data scientist at H2O AI. It's a very popular open source and enterprise leading machine learning solution and platform based company. I also did my graduate coursework at University of California, Irvine.
Well, H2O is a company I think most listeners are going to be familiar with, but for some that might not be, can you tell us a little bit about what the offering is? What is the open source tool and what are the services that surround it?
So H2O AI is a popular open source software company. That's how the company initially started. Over time, it has made its way into the enterprise market as well with the offering of driverless AI. For the open source software, one could just go and Google and search for H2O AI open source, and it's a very popular GitHub repo. And for driverless AI, also, if people are interested, they can ask for trial license, and also there is a university license for people who are affiliated to universities.
So let's just say there's a greenfield project. Someone's going to get started. They want to do some machine learning. They've got a lot of choices, sklearn and Weka and stuff like that. What draws people to H2O's tooling?
I would say completeness and scalability. So it's not binary. I would say that one would probably need open source H2O versus TensorFlow. It is that some of the features that TensorFlow is providing is solved in a more complete way from using the H2O open source offering. For the primary reason, because TensorFlow, as you will see, is maintained as an open source offering versus the open source solution from H2O is actually used by enterprise customers and in production systems as well. So where it becomes important that the last mile effort of making sure that the things are reproducible, we're getting accurate and efficient result, it's performant, those things are taken into consideration. So for example, for model deployment, there is a model artifact called Mojo, which is fast, efficient for converting or taking the model's attributes and exposing it in a way that it could be used for batch scoring and so on. So I would say completeness, performance, scalability, is the differentiator, and it's not like a binary. So if needed, it interacts well with a lot of the other open source offerings which are out there.
Very neat. Yeah, that last mile problem is a real issue. So having lots of options in that area is very important. How did you get your start in machine learning?
So, as a part of our undergrad coursework, we were always looking at different statistical models and the common use cases of clustering and so on and so forth. I was still looking from a very software engineering perspective back then. And so I was doing a lot of image processing and so using a lot of the clustering algorithms, but I wasn't quite thinking as to what we could do beyond that. So in trying to answer this question for myself, I decided to pursue my graduate coursework. And as I started doing that, it kind of helped in widening my horizon as to how we can use a lot of these algorithms in extracting more information from the data. As I started exploring, so initial exploration was with respect to information retrieval system, building search engines, and one thing led to another, and I started seeing a new world where I could use these algorithms to solve a lot of data problems. That really excited me. So that's how kind of I started my journey specifically in regards to machine learning.
And I know in your career you've had a chance to work in what I would call traditional machine learning, which is embedding in a company, figuring out how you use their specific data and these tools to deliver some service to that company, as well as what I might call meta machine learning, how you build the tools for others to use. Can you compare and contrast sitting in both of those seemingly different chairs?
So in the previous experiences, when I've worked within the company trying to solve different machine learning problems or data problems, the problems had often been with respect to scalability of a particular solution, different libraries not being able to interact with each other, versioning issues, and so, typical a lot of the engineering problems. The other problem has been as to time. There is always more problems to solve than one actually has time for. Because, and the reason I say this is because a lot of the times business has an idea on what problem they would like to solve, but it again depends on the data. So there is a lot of exploration and experimentation that goes into, and that might take a lot of time. So the question that had often been is, depending on the time constraint, how can we solve it in the best possible way? So now when I contrast it with the other persona of me being able to build tools and chains and libraries which other companies could make use of, it helps me keep those things into consideration. It helps me understand the workflow and the mindset that anyone else in the industry is probably keeping in mind when they're trying to make use of these tools to solve the data. So it helps me keep those ideas in mind, and which it helps me in making the right decisions when one is trying to decide either on the feature sets or how what algorithms to use to solve the problem, or whether it's going to be scalable, whether are we going to solve it in a time constrained way, or what other optimization problems the user might have in their mind. These things are very important because otherwise building a generic solution in ML is just a very tough problem to solve without having an idea about the user workflows that different people go through.
Absolutely. And what was your first introduction to the topic of model interpretability?
So before joining H2O, I used to work for this another startup called datascience.com, and that's where we met. In fact, Kyle hired me there. So there, we did some awesome work. We had a great team. We solved a lot of interesting problems for different clients. But one common problem that I remember clearly is that, hey, we have this client, he's able to solve this problem to 80% or 90% accuracy, and he's coming for us to see if we can help improve his model's performance. When the information gets conveyed from a client to the person who actually needs to do some work, there are different layers and the information gets distorted in different ways. We would often find that we don't have an answer to what were the assumptions that were considered while building the model, what feature sets were used, and we would often have to depend on the other person's information to extract that useful piece of information. I remember clearly we were discussing one time with you, Kyle. Both of us, we were kind of thinking that there might be a better way that we could actually query the model to get this information. And that's how I would say, for me, that idea of interpretation kind of started, is that can we think of a way where we can query the model itself for the information rather than depending on anybody else to for those answers. But we didn't know back then that there is a field such as model interpretation. So what I'm trying to say is that we had a problem where we wanted to query the model and get the information, what features were considered, what assumptions were considered, without asking anyone. And as we started exploring this problem, we realized that, hey, there is a field called model interpretation. That's how, for me, the whole idea of interpretation started. So it happened very organically. We had a problem, we were trying to look for a solution, and as we were trying to look for a solution, we stumbled into this field of model interpretation. And as we researched more, we realized that it's just not us. A lot of people from the research community and practitioners are also thinking about this problem, and it seems to be a bottleneck for a lot of other people.
Yeah, absolutely. It's very interesting how much this field has grown in so many ways. With that in mind, maybe it'd be good to do some high level touch points. What, obviously, we can touch on Lime, and by the time this airs, the author, Marco, who created Lime, and for sure listeners will know about Lime. And there's also a wide other array of different tools. Could you give a quick rundown on how one goes about providing some level of interpretability once a model's built?
Sure. So before I answer the question, so like as we were discussing on how do we go about defining model interpretation. So it's great that you were mentioning about Lime. So Lime was one of the first paper that gave us a concrete definition to how we can go about solving this problem. And the work of Marcos and Professor Samir Singh, I feel, was very important in our journey as well, is because it helped us in defining concisely how we can go about solving it mathematically, programmatically, and tooling it so that others could also make use of. How we went about defining the criteria for model interpretation was twofold. One is, can we define the interpretation globally? That is, meaning considering all the data points that's there in the data, can we figure out what the conditional interactions between the dependent, that is the response variable, and the independent, which is the predictor or the explanatory variable, is? That is, in simple terms, consider all the data points in the data set, and can we explain what are the most important attributes of the model that is contributing to the predictive power of the model. The other one was, imagine if we have a zoom lens and we are able to go and look at individual prediction and query the model. Hey, I understand globally feature 1, 2, 3 are most important, but are feature 1, 2, 3 the most important ones for this individual local prediction as well? So what I'm trying to say is that we define the scope of interpretation globally as well as locally. And I would like to add that the scope and of interpretation, my past colleague Aaron Kramer was very instrumental in helping us define the scope.
Well, that's a good point to transition into a discussion of Skater. Can you tell me a little bit about what this project is and how users might make use of it?
So, as we were discussing earlier, we came around the problem of model interpretation pretty organically. And one, back then, we were struggling to define what we actually mean by interpretation, like, as a theoretical aspect. We know that we kind of needed a practical solution, that we want to query the model and ask the question. But it could be done in multiple different ways. And as we read the Lime paper, we spoke with Professor Samir saying, I also got a chance to meet Marcos and at one of the ICML. I think that was the ICML where he was presenting the paper. It kind of gave us a concrete idea as to how we can go about defining it. When we started looking further into the ecosystem of what work has been done in this space, we realized that people have thought about this idea. It's an old concept, but the solutions are pretty scattered all over the internet, which has been a problem with machine learning in general. If we think about the different solutions that probably existed before H2O's open source solution came along, or TensorFlow, or Keras, or any of these, we see that there might be a common pattern in them, and is that consistent tooling. So consistent tooling was missing. So we thought, can we start a journey where we can see if there is a way to unify all these different solutions and expose it as an easy to use interface which could provide or enable interpretation for all forms of model to solve, different real world use cases for both practitioners and researchers. So that was primarily kind of the idea that we had started the project Skater. We started it as a complete research project. We took small steps, and as we went about exploring this option, we realized that there was a big gap. And when we actually decided to open source it, we started getting very good traction, and that also helped us in validating a point that it's a problem that other people are also interested in solving.
Did some of the use cases of people either extending it or just taking that open source project and applying it? I know you don't always hear from everybody, but did you get a sense of some of the domains and ways in which people are taking the tool and making use of it?
We did get an idea. So when I was pursuing this project with datascience.com and actively working on Scalar, whenever I presented at financial institutions, we got good idea that, hey, people are very much interested in extracting these artifacts from the model so that they could know what the things which are driving the decision, for example, credit scoring. The other use cases that we kind of realized that people would relate a lot to was around the healthcare data. People were very interested in understanding, hey, like I have all this textual information in regards to patient, or if I'm making a prediction in regards to a particular disease or so on, can I explicitly know what the criteria for this prediction? And then at H2O, the idea of model interpretation is part of the enterprise project called Machine Learning Interpretation, or MLI. And we have a separate team which works explicitly on this, and it's led Patrick Hall, one of my colleague here. From my knowledge, we have seen the system extensively used at many different financial institutions or any other place where there is a need for AutoML. But people do also want to understand the model which actually got built by exploring the exploring the model phase. They would like to understand, for scientific understanding, for engineering purposes, for optimization, for simplifying their workflow, for documentation. They would like to extract the reason codes to adhere to different policies, which may get very stringent depending on the different industry that one is working in. And we have seen quite a lot of that in financial institutions.
Financial institutions are particularly kind of novel to me because they've had a long history of doing qualification for loan and things like that. They were almost asking for data science before there was data science. But also, I don't think of a big institution like that as always being on the cutting edge. How is it that the tools got into the hands of people in those industries?
So, well, I'm not sure about, for example, the banks are at the cutting edge and they might have reason to be at the bleeding edge of the things. I can answer the question maybe in terms of like how does driverless AIs and a driverless AI initiative and the MLI is probably helping there is they have a predictive problem that they would like to solve. They have a data like, whether it's credit scoring or predicting fraudulent users and so on. These are common use cases that almost any financial institution has. And if one is using AutoML in order to solve it, they have a lot of regulatory policies because these decisions are life changing. Being if one is not approved of credit, it's affecting a person's life because the person may not be able to go and buy a house. So it becomes very important for them to be exactly sure as to why a particular prediction actually happened. And not being able to answer that question explicitly might put them not in good shoes. And maybe one of the reasons why they may not be productionalizing always the bleeding edge, but with the interpretation story or initiative, it gives them that option that, hey, I would like to use the best possible model which is out there. Let driverless AI pick up the most efficient, complex model that it could build. But hey, I have the MLI to extract the reason codes that I would eventually need if anyone comes around asking the question. So, what I'm trying to come to is that it helps in building the defense, which may be a concern.
Yeah, absolutely. And tell me a little bit more about MLI. How can a small group or maybe a medium or large group decide if it's the right tool for them to adopt?
The interpretation story comes in different forms, and almost all initiatives that we do at H2AI, we try to keep that aspect into consideration because it's very important. Not only that, like, the aspect of fairness and bias. So I don't know if the users are familiar with it or they've given driverless AI a try. If they're not, I would definitely encourage everyone to go and give a try and request for a trial license. So MLI enables a lot of different algorithms and tooling options. So if you're a group of user and maybe one is coming from different backgrounds, right? So maybe one user or a consumer is from an engineering background, the other one is a mathematician, or the other one is from a psychology background. Can we enable the interface in a way that it could be used efficiently by all three personas? I'm guessing that's what you meant. And so MLI is able to do that by offering a common interface for all these different users and enabling different tooling options and different algorithms that, depending on each person's domain expertise, they can go about selecting the one which makes sense.
Yeah, I'd love to get into a bit more of driverless AI. Are we talking just about cars or is this a broader solution?
Well, in this case, this is a broad solution, not specifically in regards to autonomous driving cars, but the aspect of bringing AutoML into the hands of all possible users. That's why the term driverless AI.
Got it. This might be a bit science fiction for today, but something as simple as like maybe an analyst working in a spreadsheet could highlight a few columns and just say, hey, give it a shot, see if you can build a model for me.
Absolutely. Yeah. And then with the story on model interpretation, our hope and goal is that we enable, any concern in regards to fairness and biasness, privacy, reliability, robustness, and most importantly, trust in the model that actually gets built on the system.
Yeah, it seems that those two things go hand in hand. There are, I imagine, many listeners, I don't happen to share this point of view, but I'm sympathetic to it, who might say, if you put these tools in people's hands and they're not educated, they don't have PhDs in machine learning, they're just going to overfit some model and then use the tool in an inappropriate way. What else do we owe those consumers to help them not hurt themselves with the tooling?
Let me answer that question in a slightly different way. So when we had started this journey, we were trying to define what do we mean by that. And we came up with this definition of a model maker and a model breaker. One may ask, what do we mean by a model maker and a model breaker? A close analogy could be tying it to the software development world where we have engineers and we have QA engineers. So engineers are trying to, write up some code to develop something, and QA engineers are helping test that to make sure that it's robust, it's not brittle, and it's considered all the possible corner cases. Why are we doing that? We're doing that so that the end user who is actually using the system has trust because he knows that it has been properly tested, validated, and evaluated. Often with machine learning, that aspect seems to be missing. So the goal was and could probably be in future is how can we bring in or enable that trust? And one idea that I personally feel could help us in bringing that in solving that problem is that we enable the model maker to define different criteria on what that trust could mean. And we allow the model maker, who is the consumer in this case, to be able to extract that information as needed to validate whether the user actually went about considering all the different features in the model, or is the model behaving the way as expected. If the model is behaving as expected, if one is able to extract those information on demand and being able to compare the assumption that went into the model and what the model is exactly doing. And if one is able to do that, then hopefully we are solving this problem of enabling trust.
Yeah, absolutely. And I think you introduced a novel idea I hadn't, that really it comes down to trust. Yes, it would be great if the operator or user or recipient of the model's output could explain to you, the tensor algebra that gets done, or maybe at some higher level what features are important. But really the key word here is trust. It's, am I convinced that I can let this thing run the thermostat in my house? Or am I convinced that I can let this machine drive me to work? That's really what we've got to achieve, is this human notion of trust, really, in addition to all the mathematical principles. Would you agree?
Absolutely. You would know that solving this problem of trust is difficult because no matter what kind of a model we build, the world changes in its own form. And how can we enable different ways of capturing the different perturbation in the data so that the model that we have defined is robust enough that it's able to adhere to the different changes that might happen to the data, but is still able to give the consistent result that is expected. So what I mean by that is, say, for example, if I'm a user and I've built my credit score over the years and I moved to a different location all of a sudden, and suddenly if I'm trying to apply for a loan, the system says denied. Why? Because maybe I've changed my zip code and suddenly I was qualified for the loan, but now I'm not. If that happens to a user and he's just dependent on this automated system, and we're not sure what was the reason that probably was driving that factor, then we kind of start losing trust. So when one is asking this question, if the system is able to answer back, hey, the reason why you probably denied credit is because of XYZ, it helps the end user in developing that trust onto the system. Another example we could probably think of is in terms of autonomous driving, right? So, like, say we say that, hey, what are the criteria for autonomous driving to reach level 5? And if some fatal accident happens somewhere and we are able to extract the reasons and say that this accident happened because of reasons XYZ, and it matches with what a human would actually go about finally concluding and not being totally agnostic to any model just based on their understanding. And if one is able to extract the same information from the model, That's the best form of trust, because now the human could say feel safe because he's like, oh, I'm using this like autonomous system, and whatever understanding that I'm able to come up with, the model is able to also give me that output that is matching my understanding. So then you kind of start trusting the system. How do we enable this explanation in human understandable way, which goes back to another point, that how do we enable these explanations in a human understandable way so that anyone, the user, doesn't have to be scientific or mathematically oriented to be able to understand these explanations. I think that goes a long way in enabling trust.
Yeah, I've always been maybe a little bit cynical in trust in saying that, okay, it's a black box. If I can observe it, interact with it, try and fool it, put it in various controlled circumstances and see how it behaves, then I can certainly build trust around it. Or at least I can observe it enough that I feel I've gained confidence. But at the same time, I don't know anything about it because I said it's a black box. Being able for the device to not only perform for me, but explain itself. I avoided that area because there was a child there is a lot different than I avoided that area because there's a blob there. Have you noticed the degree to which the insight can be informative to the user, affecting how quickly a trust is adopted?
Absolutely. Like there has been, from my experience, I've seen cases where people felt that, oh, wow, okay, this makes sense because we had like hundreds and thousands of features, and I just didn't know that these were the ones which was actually contributing to the success or failure of this particular prediction. And they felt very happy about it, that, oh, I'm able to extract this information. So now I have a defense lines which I could take to my boss or to whoever one has to answer in expressing myself, in defending myself, or defending oneself and defending the model that one has built. The other thing from my experience, whenever I've talked at different conferences and talked on the idea of interpretation, people have come up and said that, yes, we have this problem and we would actually like to use this idea or something similar to extract certain informations. Getting like what is it that explicit use case, that might be slightly difficult because of client secrecy and all that kind of stuff. But yeah, there has been a lot of movement from my experience.
Yeah, it makes a lot of sense to me. You touched on one thing in passing that we haven't given enough coverage, I think, on the podcast as a whole, not just in this interview, but it's that notion of perturbation. Can you talk about what that technique does to help us stretch our sample and how we apply it?
Sure. So let me define the idea of perturbation, right? So from my understanding, one of the most important thing in machine learning is being able to capture feature interactions. If one is able to understand how two features are interacting and how it is changing or how influential the interaction is in driving the target variable that we are trying to predict, then half or more than half of a problem is solved. So that is one, that is feature interaction. The other one is, like we were discussing, a model is as good as the training data on which it's being trained on. But the world, it behaves in a different way. So, which means that in my training sample, say, suppose I have three features: age, income, and sex. So, my sex is defined by male and female. Age groups is, in my training sample is between 20 and 30. And income is, ranging between zero and infinity, whatever that could be. So that's what my model was trained on. But when I actually deployed my system, the age group certainly changed. So initially we had started between 20 and 30, but now my age group is between 30 and 50. Now, if age is supposedly the most driving feature, what would happen is that all my predictions would probably be wrong. So, which means my model is brittle, not performant, it's not robust enough. So, the question is, how can we enable robustness of a model? One way to go about doing is that we perturb the feature space in a way that we are able to capture the changes that is happening in the world. That is, can we capture the interactions? Can we alter the feature ranges within the range that is defined in the in the training data set? Or it could also be range that we, from talking to different domain experts and so on, we have realized, or from one's experience they have realized what they would like to consider. One is able to bring those changes into the training data set. So what I'm getting into is that perturbation, from my understanding, is one way to bring in counterfactuals and examples, create additional simulated examples that which may or may not have been part of the training data from the very beginning. And this helps in capturing the model robustness or being able to train a much better model.
I can definitely understand how perturbation would work in tabular data. Like I could say, oh, this is an age column, plus or minus a value, things like that, or sample from a distribution. What does that look like in NLP or vision or audio or image or some of these less obvious domains?
Yeah, so the idea with perturbation is, like we were discussing earlier, more importantly, is to account for the changes that might happen in the world that we may not have represented in the training data set. So, like you mentioned, that we understand what it means in regards to tabular data set. Text and image are different domains. Even I would go and say that for image, just going randomly and changing a pixel is still probably a lot easier, and we would see a change in the prediction value. For text, it becomes slightly more complex because we may want to consider the semantic structure of a training sample as well. So, for image, if we are able to perturb a data set conceptually, which means that I would like to segment my image, any image representation, and I would like to change my white coffee mug with the black coffee mug, or a cylindrical coffee mug with a weird looking cup, and still see if the model is able to say that this person is drinking a cup of coffee, for example. In terms of text, perturbation, like we were discussing, becomes slightly more difficult because we want to keep the structure of a particular sentence. And we were discussing this use case where we said, what color is the house? Changing the orientation of this particular question by saying, which type of color describes my house? So the answer to both the question is probably the same if I'm training a model. But if which has never occurred in my data set, the model is most likely going to make an error. So this idea of perturbation might be slightly new in regards to text because, as we were discussing, it becomes much more challenging. And I recently came across this paper by Professor Samir Singh and his research group, where they went about keeping the semantic meaning of the text in consideration while perturbing the data set. I think it's called semantic adversarial examples or something like that. But if we search on Google on some of his work, I'm sure we'll be able to find that paper, or I can share it after the podcast.
Yeah, either way, we'll make sure to get that in the show notes. Yeah, I've started to, in my mind, equate it to being a little bit like, I don't know, stemming in natural language processing, where we lop off the endings, stop, stopped, stopping, but also seeing that sometimes that we're just extending the corpus we already have. So it can be damaging in some situations or limited in value, but does have some powerful effects here. I've seen some other techniques start to get applied to attempt to, I guess I shouldn't compare them. It's a little unfair to compare directly to perturbation because it is what it is, right? It does a good job of trying to bootstrap your data set, but we can also simulate and bring in outside data and things like this. I'm curious to see if you have observed people adopting patterns like that. The one that maybe is most close to my mind is with all this self-driving research done in California, it's easy to joke about these cars can't drive in the snow, but been very pleased to see more than a few poster papers of people trying to take existing video footage and overlay in a smart way snow or sleet or rain or these things to extend the data set in that regard. Do you see similar practices taking off?
I would say yes. And then I would also add that this problem of perturbation or creating counterfactual or adversarial examples, it goes a long way. I mean, there's a lot of research done, and people are actively using it for multiple different purposes in improving the model's accuracy. But without diving into the details of adversarial, let me also bring up that aspect of perturbation that depending on the domain, it might be easier. So certain domain data sets might be easier to perturb. For example, for image, it's easier, like you mentioned, it's easier to probably add a patch of snow in the middle of a freeway and see how the model behaves. Brought up stemming in regards to text data, but just stemming may not be enough because when we come to text, it's a much difficult problem to solve because predictions often consider depends on the semantic meaning of a particular sentence as well. So, for example, one might say, what color is my house? Okay, that may be one way to define it. The other way to define it could be, which color is painted on my house? So, the answer to both the questions is probably the same, but I went about defining it maybe because people have different experience with, say, in this case, English language, and the way they structure the sentences may be different. Now the important point being that the answer to the question remains the same, but how we phrase the question is different. Now, what if the training sample only had examples which had what color, or the sentences which are composed using what and color, and there wasn't anything which was there in the data set which included which type of color? So you'll see that the sentence construction is different. Now, if we introduce this new text, which is which color, then the prediction is going to most likely be wrong. So then if we are just considering stemming, then we probably will not be able to solve this particular use case. So what I'm trying to say is that we might want to think beyond just like, the techniques that we have been using in the past, but techniques where we also consider the semantic meaning of the text. That is one. The other one being that for some domains like image, it might be much easier to perturb a data set because prediction is dependent on the pixel densities of a particular image. It might be slightly more trivial to change it and get a change in prediction. But the important aspect there being that can we go about making this change in a conceptual way rather than just going about changing it randomly? So, what I mean by that is having control. So, for example, if we are saying, going back to our discussion about autonomous driving, if one is driving on a freeway and the color of the freeway seems to be black or blue, that we pretty much get used to, the car seems to drive pretty well. It's able to infer the objects which are there on the street, and it's able to make its prediction pretty accurately. What if in some country the color of the freeway is yellow or brown? I'm just making it up. Since the background color has changed, now if the objects appear, is the model able to predict accurately? What I'm trying to bring forward is that perturbation here could also mean, can we go about making these changes conceptually based on certain criteria and constraints? And often, from my experience, defining or perturbing whether it's image or text, depending on a particular constraint defined concept, is often very difficult. But often that might be the need for real data science use cases.
Yeah, absolutely. I think you hit on one of the key points here is we often don't have the counterfactual, and some of the interpretability efforts might be to extend the data set or mutate or perturb or do whatever to try and provide more examples, but ultimately it seems machine learning by definition will always be incomplete. It wasn't trained on the future's data, so we definitely need these tools to understand something about its mechanism.
Yeah, as we are talking about this concept, one thing which I feel we are naturally probably progressing into is scenarios. So we are thinking, oh, we are saying that, hey, what if we change a particular text or a word? What if we change the structure of a sentence? What if we change this particular image? But the important part being that we're constantly saying, what if? And the truth is that a lot of the times when we are trying to build a model, so building a model is one part of the solution, but a lot of time is spent in understanding what if. Say, for example, one is designing a marketing campaign. For that matter, let's say Nike wants to open a new shop in Southern California. Okay. And we build a model and we decided that, or LA downtown seems to be another great location to probably open a new shop. But then other criteria may come along and then be like, oh, what if the traffic on 405 increases fivefold in 5 years from now? What if the population in LA grows 10% of it doesn't grow linearly, or it starts to grow exponentially? What if weather condition changes drastically, or some other criteria? I'm making things up right now, so don't quote me on that. But the point being that we're trying to think in terms of what if.
Leads us to one good question, though. What do you see as the future for model interpretability? Many good steps have been taken, although I don't think we've closed the door. What's coming down the line?
So I would say the space is pretty new. People are still in the process of defining what they mean by interpretability. More importantly, people are trying to come up with different taxonomy for evaluating and validating interpretability, from my opinion. That is one. The other thing is, like you were asking as well, is that the success of it would depend if we're able to solve real world use cases. Some of us have been lucky enough to be working with maybe different customers where we've been able to solve this problem, so we see a green light, while others are trying to figure out where is that sweet spot. But I feel that more importantly, that model interpretation, inference, testing, howsoever we want to term it, just by itself may be a narrow field. We have to understand what it means in terms of a broader life cycle. For example, we talk about fairness and unbiasedness. Now, fairness may get introduced during the process of data collection. What if the data that I'm collecting is all just oriented to male personas and there is no representation of female? Now, if my model has to predict on female persona, it will be biased towards male. And that's just, I think earlier this morning, I came up on this blog post where Google decided to take away the aspect of gender from a lot of their vision API. So, like, looking at a particular image, you can probably say whether it's a male or a female or transgender or so on. But often these systems have been criticized lately that they're not able to do an accurate job if a person of color, which the important point being that the interpretation aspect is applied to a real world use case. So researchers and practitioners are slowly applying it to the real world use cases and solving the problem in a way where it actually matters to the user in multiple different ways, and that is helping in defining this particular field in machine learning. But more importantly, the interpretation aspect, as we can see here, also is just a small aspect, and it needs to be part of the whole life cycle. It should be like, considered during data collection. It should be considered during model building. We talked about adversarial and counterfactuals and so on. So it should be considered post model build process. So what I'm saying is that it should be considered during pre-modeling as well as post-modeling, which is, the entire life cycle of a model building or model deployment process. It should probably be considered when we are doing model testing. And we talked about briefly about the sensitivity analysis or what if analysis. And if one is trying to think of the problem in that way, then I think we might be walking in a direction where we are able to use this powerful aspect of model inference or interpretation to make a difference. And yeah, and I feel like the industry and community are slowly coming together on that ideation. People in, from different parts of the industry are working towards in solving that problem.
Absolutely. And it's exciting to see people like yourself working on that and bringing some of the tools to hand. I can certainly say firsthand I've noticed that people are not against a lot of the techniques. You just have to make it convenient for them to use it. And that goes a little bit beyond publishing a white paper. So it's great to see a lot of the technologies we've discussed today being available, driverless AI and these sorts of concepts.
Yeah, absolutely. Yeah.
Well, Pramit, thank you so much for coming on the show and sharing your expertise on these wide number of topics we touched on. Maybe to close out, tell us where people can follow you online and maybe see where you might be speaking next.
Thank you so much, Kyle, for inviting me and allowing me to share my ideas and views with the wider community. It's easy to follow me on Twitter, LinkedIn. I guess we'll be sharing the Twitter handle in some way. But if not, if people just search on my name and Twitter, it should most likely pop up. In regards to where I'm talking next, so right now we're working on some other new ideas, and I'm not quite sure where I'll be speaking next, but if as soon as I figure that out, I'll be announcing it on Twitter for sure.
Awesome. Well, I'll be following there to keep up. Pramit, thanks again. It was always good to catch up.
Thank you so much, Kyle. Absolutely a pleasure.
Thanks for listening to Data Skeptic Interpretability. Our guest this week was Pramit Chowdhury. Our theme song is Number 5 by Big D and the Kids Table. Our associate producer is Claudia Armbruster. Guest coordination by Vanessa Burciaga. I've been your host, Kyle Polich. Thanks for listening, everybody.